Hello, everyone. And it looks like at least some people were able to use the Google Doc. So please do still write your name down and your favorite open data platform or tool so that we can check those out after the session. But for now, we'll get into what we wanted to share in terms of tools and principles. And I'm gonna try to share a screen, which is going very slowly, sorry. Which you should hopefully see now. And I don't hear anyone saying no and a thumbs up. So all good. All right. So my name is Esther. Just like previously, I'm a data steward in the Netherlands. But today we also have Bosun with us. So Bosun, if you can introduce yourself, please.
Thank you, everyone. And thank you, Esther. Thank you, Lamis. Thank the entire network for the opportunity to be in your midst. I'm Bosun Obileye. I work for DataCite as the regional engagement specialist in Africa. Yeah. Oh, you want more from me?
I'm sure if people want to know more, they can also ask.
Okay. DataCite is in Germany, but I'm in Africa. I mean, if you have heard about the International Institute of Tropical Agriculture, I used to be the institutional data manager, leading the entire research data management for the institution. I initiated the open science the policy for open science, for open data, institutionalization, building a repository, getting the necessary cultural seal of approval, and then getting that repository from 0 to more than 3,000 data sets before I left the organization. And yeah, I was deep into data before I joined DataCite, where apart from my work on data, metadata, ontology, and DataCite, we push more into more of engagement across the continent. And here I am, still doing the same thing. I'm glad to be in your midst. Yeah.
Awesome. And what the two of us will tell you a bit more about today is about care principles, FAIR principles, very briefly about data management plans, and some tools to use at the very end. And with that, you will kick it off with, well, the care and FAIR principles, which are based on two publications. So you can see the one by Carol et al. Linked in the slides, and hopefully everyone has access to the slides so you can actually go to those links afterwards. And for FAIR, we're linking to not to the publication itself because it's quite technical, but there's a little bit of information on the Turing way, which explains it very nicely. But we'll delve into care first, and for that, I'll give you the floor.
Thanks, Esther. Here principles. I'm going further by saying for indigenous data governance. Both care and fear they are like 5 and 6, as we put it in this region, they work together. Fear tends to tell us that, oh, make everything available. But care is telling us that there should be some caution when we are complying with fear principle. Esther will tell us more about the fear principle. The trend is the current movements towards open data and open science does not fully engage with indigenous people's rights and interests. When we go, for instance, in our African environment, we have some indigenous people in many locations, apart from those in Australia, in Canada. When we capture their data, they cannot write, they cannot read. We have people like that. Do we consider their rights? Though they cannot write, though they cannot read. And that's where the care principle comes in. The existing principles within the open data movement, that is for FAIR, primarily focus on characteristics of data that will facilitate increased data sharing among entities while ignoring the power differentials and historical context. So there is an impact on the indigenous people when we are complying with FAIR. We need to look at their privacy because we continue to share their data. For instance, it could be a picture of somebody half naked climbing a tree. And we are trying to make reference to a particular project. We keep on sharing that image. Do we consider the impact of what we have done? So the key principle for indigenous data governance are people and purpose oriented, reflecting the crucial role of data in advancing indigenous innovation and self-determination. So we are focusing now that we are careful about individuals. When we collect data, we call something PII, personally identifiable information. Some say PI. So your data is people and purpose oriented. You are concerned about those that you are gathering their data. Next slide, Esther. So what are indigenous data? So we're going to look at some of them, but we can say that indigenous data, according to Carol, are data, information, and knowledges in any format that impact indigenous people, nations, and communities at the collective and individual level. So it is not just for an individual alone. It could be a whole community. It could be a clan. It could be an entire nation or just a community. So once you are collecting their information or analyzing the data or collecting the data and the knowledge, for instance, what kind of spear do they use for hunting? You are gathering those information. They are important indigenous data. So examples that we could give are data about our non-human relations. For instance, when you collect information about the land, the water, geology, that is the soil sample, the structure, the titles, air, the soil, the sacred ecosystem, the territories, plants, and animals. I will even go further. They are gods, demigods, or what they worship. They are part of the non-human relations. When you collect them, they are collecting indigenous data. It could also be data about us as individuals, like administrative data, legal, health, social, commercial, corporate, and even services. How will that affect indigenous community in terms of care? The way they administer their justice, they understood. There's a tribe in East Africa. The last time I went there, they were always jumping. But they have their own culture, how they administer the legal system, how they manage their health, how they relate socially, how they trade, using trade by barter. All these are part of the individuals. Then data about us as collectives. That is the traditional and cultural information, languages, knowledge, the knowledge system, ancestral and clan knowledges. All these, they constitute indigenous data. Now, on our next slide, we are going to look at care by itself. So, care, it's 4 phrases with maybe some words too, that the acronym became CARE. The first one, C, stands for collective benefit. A stands for authority to control. R stands for responsibility, while E stands for ethics. When we are talking about collective responsibility, that is the data ecosystem shall be designed and function in ways that enable indigenous people to derive benefit from the data. So whatever data you are collecting, there is this 3C. They call it C1, C2, C3. It's by the site, I said, for inclusive development and innovation. When you are collecting those kind of data, bear this in your mind. For improved governance and citizens' engagement, and for equitable outcomes. So you are not just gathering for your personal interest, you are gathering the ecosystem of your data is to enable indigenous people to derive benefit from that data. And then authority to control is very important. If you have worked with in the regional area, some regions in this continent, you find out that when you go and gather their data, if you ask them to append their signature, they can't write. So how do you ensure that they give you the authority to use their data? So indigenous people's rights and interest in indigenous data must be recognized. So how do you do it? Sometimes you write, I agree in a paper, and you take the picture with them after you have told them the meaning of what they are holding. You have to have the authority from them, they must give you. And that's why we have the 3A's also that says that recognizing rights and interests, data for governance, and governance of data. You have to ensure that this data is properly managed, and then the management follows the proper governance. The two-way must be managed. Then responsibility. Those working with indigenous data have a responsibility to share how those data are used to support indigenous people, self-determination, and collective benefit. You need to tell your respondents or the people that you are working with, the indigenous people, why are you collecting this data? You explain to them they must not be at sea on what their information, their data will be used for. So you explain to them, and that shows that you are responsible. I mean, before you bring forth provenance, you show your responsibility. And there is another R for it. You have the R1, R2, R3 that talks about for expanding capability and capacity for indigenous languages and workflow, and then for positive relationship. And finally, the ethics. Indigenous people's rights and well-being should be the primary concern across the data ecosystem. Ethical concerns must be properly addressed for justice, for future use and reuse, for minimizing harm and maximizing benefit. So I'll hand over to my colleague Esther for fair principle. Thanks.
Thank you. Yeah, so FAIR, and I think you already heard about FAIR and CARE also in previous presentations, but FAIR compared to CARE is a bit more technical. This is really more about the end side of a project where you make the data openly available, or at least available. And FAIR stands for findable, accessible, interoperable, and reusable. And so what that means in brief, but we'll go over this in a bit more detail in the next couple of slides, is that for findable, you'll need a descriptive metadata and a persistent identifier. For accessible, it means that the data can be openly available, But it could also mean that authentication or procedures are in place in order for people to get access. So it's not accessible in the first instance, but it is at least clear um, how people should obtain access. Then interoperable. That means that data can be integrated with other data sets and interoperate with other applications or workflows. And then reusable. That is more about what is the documentation available describing the data and what is the license that has been assigned to the data. And so we'll go into all of that in a bit more detail in the next slide. So if it doesn't make sense yet, that's very fair in a different type of way. So the F, definable from fair. So I just said descriptive metadata and a persistent identifier. And I think a lot of these issues are actually being resolved by using a data repository. But we'll first go to metadata. Metadata is information about the data. And so it's not necessarily the data itself, but it is any information that is needed to actually interpret and understand the data. So this is information such as who created the data, what does the data set contain, when was the data created, where and why was the data created, for what purpose, how were the data created, what type of instruments were used, what type of software was used in order to create the data set. And also information like what is the data set size? Is this very small? Is this only 3 files or is it a lot bigger? And were any standards used during the creation of the data? And so that is all very abstract, I think. And so this image on the slide actually illustrates it very nicely. So you see 3 bottles that are filled with content, with liquid. And the content, the liquid in the bottles, is called data. And then the bottles have some labels to indicate what is in the bottle, and that is actually the metadata. And so that can be very important if you want to distinguish between whether you want to drink juice, oil, or something that has a deadly skull on it. So metadata is very, very important in order to interpret whether the data is actually of use to you. So that's metadata. And And where data repositories really help with that is because they ask you to fill out metadata fields. So you automatically have to provide some of that information when you use a data repository. And they also, in general, assign a persistent identifier to the data. So that's actually something to look out for when you use a data repository, if they actually assign this persistent identifier. And this persistent identifier, so you've already been using those. So for example, the link to today's slides, that is also a persistent identifier. And I'm sure you've come across them before because publications also have a persistent identifier. Then what this slide is trying to tell you is that ideally when you use a data repository, it can be helpful to use a domain or discipline specific repository if you have one. Not every community, not every discipline has these type of repositories because it is a lot of effort to actually set them up and keep them going. But if you do have a discipline specific repository, it's very helpful to have for your type of data because it will likely be tailored to your type of data. So it will more likely to have the functionalities that you need in order to fully interact with the data and to share it in a manner that is most reusable for others. And they might also adhere to community standards, which could also, again, make the data more fair because it will make it more interoperable. So it's not just for sharing the metadata, but they'll also probably ask for more relevant metadata information. So not just the author, but also more details about how the data has been generated. And that can help with integrating data sets. But if you don't have a domain or discipline specific repository, which you very likely do not, you can always use a general purpose repository. And so one of these is Zenodo, for example, so where you downloaded the slides. And there's a couple of others in the next slide, but I just want to highlight the image again. So ideally, you start with looking for a community or discipline-specific repository. If that is not available, you can also make use of an institutional repository if you have them. For example, OpenUCT is an institutional repository. And then there's always the generic repositories that you can use. And it's very helpful. Like data repositories are my favorite open data tools because if you use a repository, then the repository is responsible for long-term preservation of the data and of the access to the data. So this is no longer your individual responsibility. So this is the best tool out there in terms of open data. Yeah, so a couple of examples here. So I already mentioned Zenodo. So this is a general repository. I use it to primarily share slides, but you can basically share anything. So you can share data, code, reports, training materials, publications, preprints. I think you can share almost anything using Zenodo, as long as it's smaller than 50 gigabytes. They do allow uploads bigger, but then you need to be in contact with Zenodo to discuss it. But in general, up to 50 gigabyte. There's also Figshare, which is similar to Zenodo General Repository, and they allow slightly smaller uploads up to 20 gigabytes. There's the Harvard Dataverse, also a general repository, but they are allowing uploads up to 1 terabyte, which is quite amazing for a free resource to allow that. So if you have bigger data, then this might be a more suitable repository for you. And there's, of course, also Africa Archive, which is also free of cost and is not a general repository because its purpose is mainly for African research and African scientists. So I wouldn't call this a general repository because it does have a more guided direction in what it tends to accept. And then for discipline-specific repositories, you can use fair sharing or retrieve data to have a look at whether there's a data repository for your discipline. And we'll actually dive into that for level 2 when we get to the more practical part. That is where we'll pay more attention to. Okay, so moving from findable to accessible, and also data repositories play a role there. So accessible does not necessarily mean open. So the FAIR principle of accessible makes it also possible for data to be available under restricted access. And so that means that as long as people have a way or a procedure to contact the individual responsible, they should be able to obtain access, but it doesn't need to be openly available immediately from the outset on. And that is different from the open data definition that we looked at in the first session, where open data is data that can be freely reused, and redistributed by anyone. And for that, it does need to be openly available because otherwise you cannot reuse and redistribute by, not anyone can do that. So fair is not the same as open, and we'll get back to that. Interoperable. So I mentioned for discipline-specific repositories that it can be helpful to use them because it will make data more interoperable. And so interoperable ideally means that data can be integrated with other data and integrated with applications or workflows. And so in order for that to take place, you would need to use similar file formats and similar way of structuring your metadata, so your information about the data, and similar ways of structuring the data itself, of course. And so for file formats, there are some considerations to take into account. Sometimes you'll use proprietary data formats, and what that means is that these formats are not always readable without having the corresponding software. And some of the software is commercial, and that could also mean that it could become obsolete in the future if the company is no longer maintaining that software. So an example is old Microsoft formats that are now more difficult to open. more recent formats are more interoperable and also openable with open source software, but the older formats are not. So then it becomes increasingly difficult to open them over time. And that is where open data formats come in, which from the definition are freely available published specifications, which places no restrictions, monetary or otherwise, upon its use. And so that means that that should be openly available in a format that you can open with tools that do not require you to have a license to it, and paid license to it, as in you don't need commercial software to open it. And so often it is possible to do a conversion from proprietary formats to open formats. So for example, a Microsoft Word document you can convert to a text document, or a Microsoft Excel sheet you can convert to a CSV file, which is an open format. But this might also result in some loss of the data because you're not using the file in its original format. And so there's lots of considerations to check out whenever you make a decision to format your files in openly or not. And sometimes, or at least my preferred way of dealing with this, is to have both an Excel sheet and a CSV file so that you have both the usability of the Excel file, but also the benefits of long-term preservation, where the data is still accessible even after Microsoft has flipped over and won't allow you to open any files anymore. And there's an image in the slide where there's some more considerations in terms of when to do file format conversions. But I'll skip a little bit over that because we do have a lot to cover today. Then for data to be interoperable, it is easier if you use metadata standards. And that means that the data is more standardized or more formalized in its structure. And this can mean general standards, such as Dublin Core, which is the standard that is also used by Zenodo. So if I share some presentation in Zenodo, it will ask me who made the presentation, when is it published, what is some generic um, data as well, abstract information, but also the language, etc. So it's already asking me about a couple of things that I would need to provide Zenodo before I can actually upload the slides. And some of these simple or general standards are Dublin Core, but also some of the domains have field-specific standards. And the one that is highlighted in the slides is ecological metadata language, and basically that is a more formalized way of to structure data in the earth and environmental sciences. So this is not applicable to everyone, and perhaps your field also might not have this type of standardized way of structuring metadata. And we'll find that out in a bit, because this is actually where we have a bit more interaction or interactive part. And so if you're able, we're going to check if you have a metadata standard available to your research field. So what we'll do is we'll use fairsharing.org, and I'll also try to see. I'm not sure if it will actually share whatever it is I'm sharing now. Do you see fair sharing?
Yes.
Okay, great. So if you go to fair sharing, and I'll put that into the chat. And if you type a couple of keywords in search through all the content, so for example, my discipline is isotope archaeology. We're going to find out if isotope archaeology has a metadata standard, and only a database pops up. So it does say that it has standards implemented. So this could be of interest to me. But I don't think we had any archaeologists, so we'll skip over that, and instead you get to look into this resource using, for example, keywords that you would normally use to look up a publication in your research field. And then I'll stop sharing for a bit. Because what we'll do is add that information also to the Google Doc. And the Google Doc also has a link to fair sharing. So I'll give you a couple of minutes to do that. And then I'll also check the chat for questions. So I'll shut up for a bit. Unless there's anyone who is now confused about what it is that we're doing, then feel free to speak up.
Clara, we're actually doing an exercise where we all go to the Google Doc and also visit the link, which is fairsharing.org. And we look up, write a keyword that corresponds to our specialization and see if there are fair data sharing standards or metadata standards for this discipline. So for example, if you look at the Google Doc, like Esther searched isotope archaeology and there were no highlighted metadata standards for that. So just look up, use a keyword that you usually use when searching like for papers for your discipline, and let's see if there are metadata standards or not. Okay, I think we have a question, Samira. Go ahead, Samira.
I've been searching for the keywords on the website, and I found a number of databases, and then on the bottom left it gives me like the standards for each and every one. So I don't know, what do I have to write in the Google Doc?
You can share some of them if they look of interest. Maybe not everything is interesting to you. I mean, we don't have the time to look everything up in detail, but it would be helpful to know what keyword did you use to get through these results, and maybe share a couple of them that look interesting.
Okay, thank you.
And I'll give you another minute for that. So if you don't get to the point where you're sharing it in the Google Doc, that's fine. You can also do that after the session, but otherwise we won't be able to get through all of the slides. So I'll give you another minute. Okay. I think people are still maybe working on this. But yeah, this is something that you can also do after the session. And I'm not sure why you can't open the link. So maybe we can, yeah, maybe if it's your connection, maybe it would be easier to do it after the session when you also don't have a Zoom going on. But yeah, feel free to ask questions. And if you run into any issues later, you can also ask questions on Slack so that we can get back to that. Okay. In the meantime, I'll go back to the slides so that we can move from interoperable to reusable. Let's see. So for reusable, and I'll go through that a little bit quickly. primarily documentation about the data is important, but also the license. And for the license, we'll also have another look at your license preferences in our second exercise. So I do hope you can see a screen, and otherwise please do interrupt and let me know if I'm not sharing anything or just looking at my face. Awesome, great, thanks. Right, documentation. So in order for your work to be reusable, you need documentation to provide context to the work, to provide context for the work. So this would allow collaborators, colleagues, and reusers of the data sets to understand what has been done and why, and not just other people, but also future you. Will you be able to remember what you've done with the data 6 months later? And for this, there's a couple of tools. So an example for tabular data is our code books, and I've included a couple of links in the slides. I'm not going to go into too much detail here now. We'll probably do that for level 2, and otherwise you have access to the slides. And also README files. And README files are in general written in an open text file document, such as TXT. To make it, to ensure that you can actually open it. This goes back to also the file formats that we discussed earlier. And in the README file, you provide some context about what it is that the README file is documenting, but also the documentation itself about the data. So there can be general information, methodological information, but also information about what reusers can do with sharing and access, etc. Or for example, citation information. Do you want people to cite the data set, or do you want people to cite the accompanying publication? And if you have to generate a lot of README files, then ideally you would set up a template. And I'll go over a couple of templates for data. So the Cornell template is a very general template, which is often shared that you can reuse. And so we're not going to go over that in detail right now. That's probably more a level 2 thing when we can actually set it up. Before we share a data, or we'll need to read this README file before we decide whether we can reuse a data set. But for now, it's enough to know that there's README file templates for data. And there's also some more information on Dryit, which is another repository. The README files for software look a little bit different because then you also need information about how to use the software. And so we included 3 examples for this as well. Again, not gonna, unfortunately, don't have time to go over that in detail, but we'll do that in level 2. And so licenses, these are very important, and I think you've also already heard about them in previous sessions, but just a reminder, this is a formalized agreement of what reusers can do with data, software, also with publications. And that also means that if there's no license, it doesn't mean that you can just reuse things. Same thing with stuff on the internet. That actually means the opposite. If an image does not have a license associated with it, that actually means that you can't reuse it without asking the original author for permission. And so licenses are a way to circumvent all of this emailing and contacting by indicating upfront what people can do with the data, the software, the publications, etc. And so software and data have different licenses because software and data are a bit different in how they work. And something which is more aligned with the CARE principles are also licenses such as traditional knowledge licenses. I'm not sure if it's called a license or a notice, but yeah. So there's also ways to incorporate the CARE principles into your license because the licenses are otherwise actually quite more technical and fair focused, I would say. But those are licenses. And so for data, we often see the Creative Commons licenses. There are also other licenses, but we'll go over the Creative Commons licenses for now. And so these are all these licenses where you see a CC, which is the Creative Commons abbreviation, and then all these letters such as BY, and BY means that attribution is required if you see anything with a CC BY license. If you see anything with a CC0, it means that the original author has released copyright and it's now in the public domain. And then you do not have to provide attribution, and you can do all of the things with the image or the data. You can copy and publish it. You can use it for commercial use. You can modify and adapt it and share it under a different license if you want. You cannot share it under a different license if the letters SA stand in this letter abbreviation license, because SA means share alike, and that means that if you use anything from which is shared under CC by SA, you'll need to share this under the same license. So for example, the image in the slide is also licensed CC by SA. And so I put that into the slide in particular because I tend to share my slides using CC BY only. But this image in particular is shared under CC BY SA, so I cannot share that under a CC BY license because that would infringe this license. So that's what CC BY SA means. Then when you see the letters ND, which mean non-derivative, that means that you can't actually modify and adapt the original content. So for some of the data, that doesn't make a lot of sense. For some disciplines, we want to cherry pick some data points out of a bigger data set to reuse only those. But non-derivative would actually not allow that type of reuse. It does make more sense for other disciplines. So for example, if people do interviews with individuals, then it might make more sense to apply this license, because otherwise maybe people start pulling quotes out of context and you don't want that. Then this license makes more sense. So this is really dependent on your discipline. Then there's the letters non-commercial, or NC, and that means non-commercial use. That means whenever some type of profit is being made, it can't be used for these purposes. And then you can actually combine a lot of the letters, and that just means all of the restrictions from the letters apply. So if you do a CC BY non-commercial essay, it means that you, when you reuse it, it can't be for commercial purposes, and then you'll have to share it under the same license, share alike. So that's in short licenses for data. And then we also have licenses for software. This is a bit more complex because software in itself is a bit more complex because it's executable. But in general, there's a distinction to be made between permissive licenses, which allow a lot more reuse. So for example, compared to CC BY, this looks very much like a CC BY license for data. And those are Apache, BSD, and MIT. And then the more copyleft licenses, which GPL is the most well known. And that means that whenever people apply a copyleft license, it looks a little bit more like the CC BY SA, where if you use any software with a GPL license, you incorporate that into your own software. That means that you would then have to share any derivative software under the same license, and also the source code. So it's even a bit more restrictive, so to say, that the source code must be openly available under the same license. So that's a big distinguishment between these two types of licenses. So I won't go into a lot of detail because it's open data, not open software. But if you're using software, then this is something to take into account. And what we'll do for the next exercise is indicate in the Google Doc which license you prefer. And you can add that for the data that you prefer, or for software if you want to look over software. And I think in the Google Doc, there's 2 links that you can use to the Data Creative Commons license chooser, as well as for the software license chooser. So it might be easy or easiest to use these 2 tools. Let's see if I can. The Zoom bar is very inconvenient in front of all of my. Yeah, so in the question itself, there's a link to the choose the license for data and also for software license. So it really depends what you want to share. If you only want to look at data, that's fine. You might already know which license you would prefer. You've already heard about licenses, so maybe you're already like, CC BY it. This is my license. So then you're done within a minute. But we'll give the rest of the exercise, I think, a couple of minutes, so that we can try out the tools. And then I'm already scared looking at the time, but I'll shut up there. Unless we have any questions about how to complete this. So I already see some answers. So I think it would be good to continue also in terms of time. So if you can't use the links right now, or if you're still thinking about it, that is absolutely no worry at all. You can, this is also something to consider after the session, to think about what license you want to apply to any data shared, and will be more relevant even in level 2, but then you already have an idea of what is available. And yeah, please, if you're watching the recording, then please also add your name to the document and add your preferred license. Okay, then I'll just go over another slide, and then maybe it's better to just go to Q&A, but I'll, no, don't do from the start. This is terrible. Always when you're in a rush. But I just want to highlight a bit. Okay, it's going to be an ugly presenter view because I don't have the patience for a slide. Right. Apologies about that. So just to summarize what FAIR is. So FAIR is our principles. So this doesn't mean that that's a standard. So the FAIR principles are recommendations to make data more reusable. And as you've seen throughout the session, hopefully that can imply using a standard, a metadata standard, for example, but it doesn't mean that FAIR is a standard to adhere to. FAIR is not the same as open. So I mentioned earlier that FAIR data needs to be accessible. So that means that it can also be under restricted access. It doesn't need to be open. That's where it's different from open data. FAIR is also not a tool. So there's unfortunately no one-size-fits-all FAIR tool which magically makes you all of your data FAIR. That's unfortunately not how it works. But as you've seen in the exercises, hopefully there are some different tools available within your discipline to make data more FAIR. But yeah, no one size fits all. I think here we might need to move to questions and answers, unless Bosun, do you want to do maybe the data management plan before?
I think we should move it to part 2 because of the time.
Let's do that. You were right. Okay, then let's move to questions and answers, if you still have the time, because we have reached the end of the session. And yes, Quarto is free to use. Can highly recommend if you want to try out Quarto.
We have some couple of questions in the chat.
Yeah, I am wondering if, Paul, is your question answered about why do we have different licenses? If Paul is still here. Yeah, otherwise we move to a next question because I did try to explain that a bit in the chat. Bosun, were there any questions you wanted to answer?
There is one that I did not respond to because I felt the answer is not one cap fits all. The question is, what will be the role of the government in the way to secure data, precious data, indigenous data? So I'm being asked the role of the government.
Please, I can clear my idea about that question. If I don't know if you understand it.
You may clear it. Yeah.
Okay. I consider that information data is very important, very precious, to be not taken account by the government. When we are talking about indigenous data, is very important. So we cannot, everybody cannot stand up and they try to secure data and I don't know, to let it open like this, because we know that information data is a strategical element for governments, and we cannot secure, we cannot collect every data to be open. That is I'm saying that it is a strategical, and it must be a policy about that data, instead of information data from universities, research results. That is different. But when we are talking about indigenous information, like information about soils, mines, and so on, environment, and so on, I think it is very important to be strategical for this, to secure them. I don't know if I try to be understood by, that is my idea.
I think I got your question now, and I agree with you.
Thank you.
Yes, the government should have a role. For instance, I'm aware that some countries in Africa establish policy or regulation for data protection. Some countries, including South Africa, Ethiopia, Nigeria, Kenya, Ghana. I'm aware that they have already made that into law to protect data that relates to their citizens, whether it is about where they are living, their land, anything that can identify individuals, just like what we have in the EU. So it is pretty much good that government should be involved.
Yes.
And I totally agree with you. To make this to work, government has to put in frameworks that will ensure that indigenous data, they are properly protected. Yeah, I agree with you.
Okay, how can we manage to sorry, how I know that we have an institutional repository, national and regional repository. How can we manage to that different stage in a country? Must we begin with institutional as the university before going the one university, go in consortium with different university before going to national level, before now think about how to collaborate with regional and so on and so on. What would be the strategy? I don't understand you, please.
You're muted, Bosun.
Sorry, I'm so sorry.
Okay.
I got your question.
Okay, thank you.
In case of having, where should you start from? Is it from the institution, state, or province, or the nation? In terms of having your data repository. I won't say what I'm going to say is the absolute best strategy, but I need to tell you that it is always the best practice that institutions have their own institutional repository. Now, when it comes to integrating it with the national, Tanzania is doing something close to there. That's right now. I'm aware about it because I've met with the technical people working on that. And it's also absolutely possible after you have had your institutional repository in which you can manage internally by your data stewards or data librarian, so that those go for the period that they should be on embargo, those that should be open immediately, which you comply with open access. Remember, Esther told us fear doesn't mean open, and that is how it really, really stands. So it's always good that you have your local, which will be integrated to the upper one. And one thing that you should know is that DOI has to be one. I mean, your identifier, the PIT, you should try to use one with rich metadata. And then you can do what is called integrations. I hope that is clear. That is always the best practice. If you do it from the top, it's going to be messy. It's like if you are doing, we call something ontology, we have a tool called Protege. You have to do it, start from the small, then you begin to branch out. So that is, it should be done.
Okay.
Yeah. But you can have your strategy and decide that it's going to be from the top down. I'm sure some problem will come up in the future. Yeah.
Okay. Thank you. Thank you very much.
You're welcome. Esther, what you? Sorry.
No, thanks for going in to all of that. I don't see any raised hands. And also, I think no responses to the questions in the chat where we already added some answers. So I think we might have covered everything actually.
Sorry to interrupt, but I do have a question. I'm also a trainee because I'm new to the concept of open data. But when we talk about care in data, does it only apply to indigenous people in the sense of them being endogenous, or for example, it also applies to, let's say, if I'm working with data with patients data, does the care principle sort of also apply to that I have to, like, because patients are also sort of vulnerable individuals? So this is my question.
Okay, thank you for the question. Care focus on indigenous people, but that principle, we apply it in data curation. When you collect your real data and you want to publish, you look at some sensitive information, whether it should go out. In the US, there's an established law on how you manage health data, which is HIPAA, H-I-P-A-A. The EU GDPR addresses that. In Africa, we do not have specific, except that we have data privacy laws for some different countries. In data curation, we try to hide what we call personally identifiable information, which could be a form of all this health data or data that could be used to identify a data subject. That is someone that you have collected his or her or their information. So that kind of information, you have to hide them. We call them anonymization, or remove them completely before you make it open. So they need to be protected. I would not say that it is care, but care principle applies to those kind of data also, because care principle is saying that this sensitive information carry the data subject along. Make sure you consider them, get their authority, and be responsible, be ethical. And ethics is where you are talking about when it comes to health data. Invariably, what I have always told those that I work with in the past is don't expose personally identifiable information. You can give a link for those that want to reuse the data to contact the data creator or the data owner. That was what we used to do in those states, yeah.
Yeah, I think it makes sense, yeah.
Yeah, I agree. It's not just for indigenous data, or at least this is how the principles were constructed and set up, and it's obviously very important, but I think it can apply to any community involved in research, also citizen science, or also patients, etc. So And even if you think you don't directly involve a community, research always has some broader impact, and it's important to consider who needs to become more involved in that and who is it benefiting. So I think care is super important for any research project.
Yeah, thank you. It's a great answer, because I think this would apply to all of us, since we come from different disciplines. We deal with different types of data. So I guess now what you're saying is that the care principle, we should always have it in mind when there are some sensitive information that would expose the identity of someone, for example. And that this makes perfect sense. So I guess if there are no more questions, I would really like to thank our facilitators for this amazing session. And it was really like the perfect ending for our level 1 of training. And we're really looking forward to seeing you in level 2. And thank you also for all our trainees for hanging in. And I know it might seem a lot of information, but we hope that you take some time to digest it and sort of apply it to your specialization, because the information is general, but then it's also good for all of us to go and see how it relates to our field of work and our specialization. So really thank you all very much. And as I said, this is the end of level 1. It was an amazing journey. Really, we learned a lot from our trainers, from our trainees. So we thank you all very much, and we hope to see you in level 2. No sad faces, because we'll meet again in level 2.
Thank you.
Thank you. Emmanuel, if you'd like to say anything.
Oh no, I think you've said everything, Lamis. It's been a wonderful journey, much more wonderful than we initially anticipated. And I'm so grateful for our trainees, to the level of interaction and how they were sharing their experiences have been so wonderful. And we are so happy. We are quite excited about level 2. I'm quite excited. I can't wait for level 2. So yeah, we'll all see each other at level 2. Yeah, thank you very much.
Yeah. And just to end, we will be sending you guys, the trainees, the end of the training survey for you to fill out. And yeah, we hope to see you again at level 2. So bye-bye, everyone.
Bye.
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 Bye-bye.
Bye.
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 Bye. Au revoir.
Bye. Bye.